Hey everybody, today what we're working through, you can see on the title, we're going to factor something called a simple trinomial. So what we're going to do is start extending our factoring from more than just a common factor. And you can see in the green there, we're going to talk about this expression called x squared plus bx plus c. So today we are factoring simple trinomials. Let's jump right in. Take a look on the screen right now, and you have three expressions on that screen that I think can give us like a nice baby step into today. So what I want you to do is to try factoring those three expressions on your own, okay? Do them on your own, and then we'll come back and we'll check and see how well we're doing. Okay, pause the video now. Okay, we're back. So you're taking a peek at those three, and I'm hoping that when we see the first problem, we say, hey, how many terms do I have in that expression? I have 2. And I'm looking for a common factor. And so I notice that there is a 3 in both of those terms and at least one x. And now maybe I'm going through to reverse multiply and say, what would I multiply a 3x by to get me back to a 3x squared? I need another x. What would I multiply a 3x by to get me back to 24x? And there's my plus 8. Okay, if that one stumped us for a bit, and now you got a little reminder of, common factors, then I want you to pause the video now and finish off B and C. Okay, pause it now. Okay, we're back. So you now take a look at B, and we look at our coefficients of 36, 45, and 45, and I can at least see that there is a 9 in all of those. I scan across all three terms, and I notice that each of them have at least one x, but they don't all have a y. So there is my greatest common factor. I'm going to factor that out. Okay, let's reverse multiply. What would you multiply a 9 by to get you up to 36? You already have an x, but if you look back to the original, you need 3 of them, so we need 2 more, and you need all of your y's. Okay, what would you multiply 9 by to get you back to negative 45? That's a negative 5. You need 2 more x's and all of those y's. And to get your last term, if you multiply by negative 5, you have enough. Okay, hopefully we check out on B, and now we're moving our way into C. We scan our way across and notice that you can at least factor out a 4 from every term and 2 x's, an x squared. So when we go ahead and we tackle that, that is going to leave you with an x squared, a single x from the first term, and a minus 6 in the last term. Now, if you were able to get down to those 3 orange expressions, I think you are doing great. That is great feedback. You are quite comfortable to pull out a common factor. However, I want to draw to your attention that problem C, that's not factored. Remember, we have that understanding that when we're asked to factor, we are asked to fully factor. Break it all down. Notice, though, your 4x squared is your greatest common factor. So you did a great job in pulling out the most you could. Our problem becomes the trinomial that you have afterwards. That x squared plus x minus 6, that can be factored further. Now, I would have no problems or no concern if I was looking at that and saying, well, I don't know how that factors. But let me just draw to your attention the green. So if I took one more line and I wrote that as 4x squared times, and I focused in on that trinomial you see, if I took an x plus 3 and I multiply it by an x minus 2, that actually gets me back to x squared plus x minus 6. Take a moment and expand those green brackets and notice you do get back. That green would be considered fully factored. But we don't know how to factor that yet. That's what we're going to talk about today. One little side note, and I want to just draw your attention over to the side in gold. We didn't do anything weird there. So I want to make sure that we understand that you are doing the same factoring you have done over and over again. We're just extending it. I want you to imagine that I gave you the number 30. and I asked you to factor that. Maybe you would sit there and say, hey, well, that is a 2 times 15. You factor 30 into 2 times 15, but I say, I need you to fully factor it. And you might go, oh, but wait a sec, that 15 could factor further. 30 is 2 times 5 times 3. That's all we did in question C. We factored it, and then we realized the second factor could factor further. Can I get you to look back at our solution to C? You took the original expression and you broke it up in your factor tree. But then you found that that second factor can factor further. That's all we're doing. Okay, I want to zero in on that trinomial that we just dealt with, and I want to talk a little bit with regards to factoring. So in order to do that, I think it's worthwhile for us to spend just a couple minutes going through and expanding and then simplifying a few expressions. So what I want you to do is to go as fast as you can go and simplify the 3 expressions you see on the screen. Okay, pause the video now. Okay, we're back. So if I go through pretty quickly, we should have been good to get that as our trinomial answer. We should have been good to get that as our trinomial answer. And we should have been good to get that as our trinomial answer. So what I want you to do is to take these 3 problems, and we're going to spend a moment trying to go backwards. Notice what we're talking about is being able to take the gold and factor it. So really, I want to be able to give you the gold expression, and you tell me that that came from a plus 3 times a plus 2. Or in B, I give you the gold and you tell me, oh, that's got to be an x plus 4 times an x minus 3. And same thing in C. How do I know from looking at the gold that that's an m plus 1 times an m minus 5? Okay, I want you to take a moment, or even take longer if needed. But I want you to try to imagine that I've given you the gold and you are trying to work backwards to the original expression, to our factors. Let's try to look for a pattern in what I see in the gold, and how could that help me to figure out what the original factors were, the white. Okay, pause the video now. Okay, we're back. So what I'm going to do is just get rid of those green arrows, just so we can clean some things up a little bit. We understand the idea that we're just factoring. And maybe we were zeroing in on the numbers. Like, I hope there wasn't a part of us that looked at A and said, how could I tell that there was A's in there? Like, I hope that that's obvious to us. So instead, what we were looking at was, how can I tell from my trinomial that that may have came from the numbers plus 3 and plus 2? Same thing in blue. Or sorry, in B. How could I tell from my trinomial that that was a plus 4 and a minus 3? Same thing in C. Why was it a plus 1 and a minus 5? Okay, if we had some struggles trying to find a pattern, I want us to take another moment to try to see. Okay, pause it now. Okay, and we are back. I am hoping that there's some extent we saw a relationship between the 2 blues in A, let's say, the plus 3 and the plus 2, and we were able to tie that together with a positive 6. You found a pattern that then applied or repeated to B. A plus 4 and a minus 3 somehow gave you a minus 12. And then in C, a plus 1 and a minus 5, I'm hoping that that was just confirmation for the minus 5. Okay, I am hoping that we can take a peek and notice that those blue circled constants inside each bracket are going to multiply to give my green. So when I take a look at all 3 golds, let's look now in A. I have a positive 6. Well, two numbers that multiply to give positive 6 are a positive 3 and a positive 2. Look in B. Two numbers that multiply to give a negative 12, a positive 4 and a negative 3. Look at C. Two numbers that multiply to give negative 5, a positive 1 and a negative 5. We can see the multiply. And we actually know why it's the multiply because that's how we expand the brackets. Okay, can I get you to zero in on B, just because I think it's got more space for us to talk about it? When we examine the two blue circled terms and we say, hey, 4 and a negative 3, that's what gives me negative 12. Two numbers that multiply to give negative 12, positive 4 and negative 3. Yeah, but there was also a lot of other numbers. Like maybe it was a negative 4 and a positive 3. Maybe it was a negative 6 and a positive 2. Maybe it was a positive 6 and a negative 2. Maybe it was a positive 12 and a negative 1. Maybe it was a negative 12 and a positive 1. We have all these other combinations of things that could have existed, but didn't. So how can we tell then that it had to be a positive 4 and a negative 3? Here's where I'm hoping we start to look at the other numbers in our trinomials. Like, how can I tell that it had to be a plus 4 and a minus 3? Well, it added together to give me a positive 1. And if I was to include the possibilities that we see in our brackets in our list of possibilities that we see in the the orange, you'll notice that that is the only possible one that gives me a sum of 1. Negative 12 and 1 doesn't work. Positive. Those don't work. Well, negative 4 and 3, if I put those two things together, it gives me a negative 1, close, but not a positive 1. That only when I combine those two values do I get the positive 1 and the coefficient on my single x. And maybe we can backtrack to A and notice that if I take 3 and I add it to 2, then I do get my positive 5 when I collect those. And we get a little confirmation in C that when I collect a negative 5 with a positive 1, that gives me a negative 4. And maybe we can notice that this coefficient on my middle term, that single variable term, seems to come from a sum, adding the two constants inside the brackets. I think us just spending a little bit of time on those three examples is going to help us to see how we can factor our simple trinomials. So what I want to spend our time doing is let's get down a note so we can formally have it somewhere to reference, and then let's spend the rest of the day today just getting practice at factoring. Okay, let's get down that note. Okay, can I get you to write down nice and big across your page that simple trinomial? And I want to nail down a couple things to it. You can have that straight on your page, but I'm going to put a little heading down, and I don't care where you get this. Is it below that trinomial? Is it above? But that is what we would call a simple trinomial. And it's not a simple trinomial because it's easy. Like, don't mistake the word simple. What it means is this coefficient in front of our squared term would often be denoted as A. So what you're going to see when we progress our way through more complex trinomials is that we're going to have an A value there that we can see. We don't see an A value there, and so we know whenever we don't write a coefficient, that means that the coefficient has a value of 1. So really all we mean when we say a simple trinomial is that our leading coefficient, and you'll often see it denoted as A. I just don't want to confuse us with notation, but our leading coefficient, the coefficient on our squared term, is 1. That's what we're talking about. And anytime we see a trinomial where that's the case, it would be referred to as a simple trinomial. Okay, what did we learn from those last three problems? Well, the first thing we learned is that value at the end represents the answer we got when we multiplied. So that's what we call a product. And the coefficient we got on our single variable term, an x, an a, and m, that was the answer we got when we added a sum. So if I was to go through now and have to factor, every time we factor constants, we tend to ask ourselves a question like, hey, what are two numbers that multiply to give 15? Or what are two numbers that multiply to give 20? When we have a simple trinomial in front of us, we got to ask ourselves two questions. We start with our product because there's only a limited number of factors to things. So we would say two numbers that multiply to give C. That's what we're looking for. Two numbers that multiply to give C. That's going to narrow down our quantity of choices. But then we got to follow it up to get the right choice by saying and. Now, sometimes you'll hear the words add. Sometimes you'll hear people say like two numbers that multiply to give C and add to give B. I don't think that that's generally accurate because sometimes it's going to be us subtracting them. So I tend to talk about two numbers that multiply to give C and come together, like collect to give B. And there you go. What we're going to do is we're going to work through that little algorithm that you see in red. For us to be able to factor that simple trinomial, we need to find two numbers that multiply to give C and come together to give B, or collect to give B. Okay, what I want to do is I want to spend the rest of the day getting used to that process. This is going to become so important for us. So let's jump right in. So what you see on the screen then, there are two simple trinomials. We can take a look at A and take a look at B. Okay, what I'd like you to do is let's see if we've kind of picked up a little bit of the patterning and a little bit of that process. I want you to try to factor A all on your own, and we'll see how it goes. Okay, pause the video now. Okay, we're back. So if we were taking a look at that little bit of patterning, then we should have been looking for two numbers that multiply to give negative 10 and then add to give negative 3. Okay, so we're going through our possibilities, and maybe we go, okay, two numbers that multiply to give 10, 5 and 2. And you'll notice that 5 and 2 are 3 apart. Now, how could I combine 5 and 2 so that when I put them together, they give me a negative 3? Well, first off, if I'm going to put those two numbers together and it's going to give me a negative, then the bigger one must be negative. Well, now, if I lose $5, then I want to find $2 in order to put me down 3. There's the signs of my integers. And so I can do a little check. Negative 5 and 2, if I multiply them together, give me negative 10. And if I collect them, give me negative 3. I've now found my two constants. Okay, I'm going to get rid of everything that I wrote so that now I know that that's equal to my binomial times my binomial. I'll have an A at the front of both brackets, and then I had my minus 5 and my plus 2. Now, a couple quick things as we talk a little bit about some formatting and some theory. So let's deal with the formatting first. Make sure, from a theory standpoint, as I say theory, that had you written A plus 2 times A minus 5, then I would argue to you, obviously, those are the same thing. It doesn't matter what order we multiply in. 3 times 2 is the same as 2 times 3. So if you had given me the gold or the green, you are good. Okay, the second part for us is a little bit of theory with regards to our brackets and the rest of the bracket. That there's some patterning that I want to draw your attention to in question B. So we're going to use B to talk about it. When you take a look at that trinomial, I want to really nail down parts of the appearance of it. so that we can see what makes up a simple trinomial, maybe even a little better than before. Okay, first off, I know that that's a trinomial because it has 3 terms. But it's a special type of trinomial, a simple trinomial, not only because it has the 1 coefficient out in front, but it's also because of the pattern within the expression. If you notice, your 3 terms follow a pattern. The first term is a squared something. Okay, we can see the squared, I've circled it. I'm going to get rid of that squared, or that circle, I should say, so I can specifically circle the x. I see there that I have a squared something. Now you'll notice that my middle term is a single of that something, the same thing. And then in the end, my constant. That really fills out what makes up a simple trinomial. It's a squared something, a single something, and a constant. And the leading coefficient is a 1. So if you can look at what I've just highlighted in problem B, and now let's go back to problem A. When you take a peek at A, you will notice that you have a squared something, a single something, and a constant, and that squared something had a coefficient of 1. That's what allows us to factor using that process, that algorithm that we've been learning. Okay, I want to give you a moment now to play around with B and see if you can come up with what we've got in B. Okay, you work your way through, pause the video now. Okay, we should be back. I'm just cleaning up a little bit what I had in that expression. And there we go. Okay, so you see your squared something, single something, and a constant, and you go, hey, that's 2 binomials multiplied together. So maybe you're saying you know it's that. Maybe you're even saying, I know that an x has to go at the front of both of those brackets. Now you're playing that little game. 2 numbers that multiply to give 12 and add to give 7. Okay, you're going through all the factors of 12, trying to find 2 numbers that could combine to give 7. And hopefully we're coming in on a positive 4 and a positive 3. Nice. Same thing as stated before, and this is the last time I'm going to write it. Had you given me an x plus 3 times an x plus 4, you are also correct. Okay, the rest of today is about us getting practice trying to build up some instinct on it. So let's jump into a few more problems. Now, okay, you take a look at C and D. And for all of these problems as we're moving forward, I want you to try to pause the video and try them on your own. Okay, we're back. So we see we've got a squared something, single something, and a constant. So we're playing 2 numbers that multiply to give 16 and add to give negative 8. So I would love it if we started to build our factors as we went, like honestly, working left to right. So we take a peek and we've got a y, and now we're trying to think of the first one of those numbers. Well, 2 numbers that multiply to give 16 and add to give 8 could be 4 and 4. Now I need that to be a negative 8. So the only way I could put those 2 4s together to give me a negative 8 is if they were both negative. And now what I have is a little bit of a check. That if you notice, a negative times a negative gets me back to my positive. Now I know that I have good factors. Okay, all we got to do is talk a little bit of formatting on C. I want you to take a look at my 2 yellow factors. And I'm just going to get rid of those blue arrows just so we can talk a little bit about some form. You came up with 2 factors, y minus 4 times y minus 4. And you are correct on your factors. But when we write that expression that way, that's not the best way to write it. Because I have something times itself, the best form for that expression would be as a power. We should actually write that one in the green and write it as a perfect square. Okay, that is a should case. That is not a must. But I am telling you, with where we go with some stuff, you're going to want to write that way. That if we don't and we leave it as the gold, you're going to actually miss some patterns. Okay, I'm hoping everybody now would write the green as their final solution. Okay, let's pause the video now and give D a shot. Okay, we're back. So you take a look at D, you notice you have a squared something, single something, and a constant. So we know it's binomials. You can now go through and say, okay, I need two numbers that multiply to give 9 and add to give 10. Well, I think a lot of us would have defaulted to 3 and 3. But as you notice, trying to put together those two 3s, all you can make is 6 if you add them or 0 if you subtract them. That's all. So that doesn't get me to my 10. But if you take a look, 9 and 1, those can get me to a 10. Quite often when we think of two numbers that multiply, we don't consider the number itself and 1. Now, we take a peek at that. We can get a 10 if we add those two numbers together. Our problem becomes we need a negative 10. So that means that I need a negative 9 and a negative 1. You take a quick peek. A negative times a negative gets me back to my positive. I feel confident. I'm ready to move on. Okay, the nice part about all of these factoring problems is there should never be a time where you walk up to me and you hand in a factored expression and you say, is it right? Did I get it right? There should never be a time where you doubt that. That doesn't mean that you get them all right. You might walk up to me and you might say, well, I had a minus 3 times an a minus 3. But when you look at that and you try to re-expand that, you would go, well, that's an a squared minus 6a plus 9. Oh, wait a second. That doesn't get me back up to the original. I know I'm wrong. So you get rid of it, but it doesn't mean that you know what to replace it with. At the very least, when we produce factors, we should be able to check and see whether we get back to the original expression. Okay, let's try a bunch more. Take a look at E and F. Okay, I want you to work your way through E and F. Pause the video now on E. Okay, we're back. So you take a peek, you notice you have a squared something, a single something, and a constant. Nice. But then you go, wait a second. That's not a simple trinomial because I don't have a leading coefficient of 1. It's something else. And then you throw your hands up in the air and you say, I don't know what to... No, we're going to persevere. So here's where we want to really start laying the groundwork for what I would call to you as your factoring checklist. It's really a decision-making tree. You see something and then you decide, okay, well, I'm going to try this as the first thing I'm going to do. And if that doesn't work, then I'm going to try this, and I'll try. And then if that does work, then that's going to take me in this direction, and then I'll try this. Or maybe it takes me in this direction, and I'll try. But what you're going to come to is a decision-making tree. It's a factoring checklist. If I see, then I try, and then I continue on. So let's take a look back at problem E. And I want to make your first step always the same. Okay, first thing we always look, how many terms do we have? And we have 3. The first thing I always look for, my common factor. I want you to notice we've gone through a few problems today, and I've probably already got to the point where I made you forget about common factors. Okay, let's take a look at all 3 terms. I'm going to common factor if I can find one. And when you examine all three of those terms, I hope you see that you have a factor of 3 in all three terms. So if I factor out that greatest common factor, then that leaves me with an a squared from the first term, a 3a from the second term, and a positive 2 from the last term. Nice. Okay, now that I've factored that, this was a problem where we would exhale and go, oh, I'm done, and move on to the next problem, where now we notice, wait a second. Inside those brackets, I still have my squared something, my single something, and a constant. Maybe it factors further, and look, it's now a simple trinomial because it's got a leading coefficient of 1. Okay, let's see if we can factor further. I'm looking now for two numbers that multiply to give 2 and add to give positive 3. So if I get rid of that blue, I am hoping that we can see we would still have the 3 that we had from our first factor. And now I could factor that into an a plus 2 times an a plus 1. Two numbers that multiply to give 2 and add to give 3, 2 and 1. Okay, you take a peek at that solution and that should look familiar. That's question 1C from today. We had a trinomial, we pulled out a common factor, and then we found out we could factor further. Okay, there's the beginnings of our checklist. And I want you to get some practice with it. So I'm going to guide you through F a little bit. Let's take a look at the expression in F. I want you to try it. The first thing we're always going to look for, a greatest common factor. Okay, pause the video now. Okay, we're back. So I notice that I do have a 2 in every single term, and I notice that I've got a y in every single term. So I can pull out that common factor, and when I do, I'm left with an x squared, a 10x, and a positive 25. There, I just pulled out a common factor. Nice. Okay, look what I've got inside the brackets. I've got a squared something, a single something, and a constant, and I notice it's a simple trinomial because it's got a leading coefficient of 1. Okay, I think this is a moment for you now to see, can you fully factor? Pause the video now. Okay, we're back. So you take a peek at that then, and we can say, hey, two numbers that multiply to give 25 and add to give 10. Well, that would be a 5 and a 5. Remember, we don't like to write that in the green, but it's acceptable. But because we have two of the same factor, I am strongly recommending write it as a power. There's your perfect square. Okay, if we were able to work our way through that, I think we're doing great. Let's tackle a couple more. Okay, I want you to take a look at the screen, and here's where I'm going to build up to some doozies. We're going to get a little bit of practice with some problem solving. I want you to try to tackle these last 5 like a difficult practice test, like a difficult, a little challenge grouping of problems. I want you to pause the video and I want you to try all 5. I'm going to then come back and we're going to go through solutions for all 5. Okay? Good luck. Pause the video now. Okay, we're back. Okay, here we go. Some of these were really difficult. So you take a peek and you'll start to notice, wait a sec, we got multiple variables in here. Well, that's not a big deal because question F had multiple variables. Okay, but take a look at G. You'll notice you don't have a common factor in there. Okay, so how can I tackle G? Well, you will notice that I follow a certain pattern again. I have a squared something, a single something, and none of them. So rather than maybe saying a constant, I say none of them. But if I go the other direction, I then have a squared something, a single something, and none of them. That's actually the most generic way of talking about a special trinomial. So I want you to zero in on what I'm going to circle in green. Two numbers that multiply to give 1 and add to give -2. Okay, how are we doing on -1 and -1? Okay, so how does that factor? Well, I go through to build up my factors, and I'm going to have an x at the front of both brackets. Yes, that makes sense, because look, when I expand those, I get an x squared. But look at what happens when I expand to get my last term. That would be a y times a y that gives me y squareds. I need them to have a -1 out in front, so I'm just going to write in my negative. It would be bad form to write in the 1. And I want you to take a peek at that gold. That gold is going to go through, and if I re-expanded that, I'm going to get back to my original. I'll get an x squared at front, then I'll have a minus xy and another minus xy, so there's a minus 2xy's, and then plus my y squared. Okay, so me being able to factor with that second variable really wasn't any more difficult. I just had to remember that the variables got tacked on to the end. Okay, I'm hoping we look at that and we go, hey, wait a sec, we got a form issue. Those are two of the same brackets. Let's write it as a perfect square. Okay, if we got over a bit of a hurdle there with the two variables, then maybe this is a chance for us to practice on the rest. Okay, pause the video at any point if we made a mistake and make sure that we try to clean up the stuff and attempt them again for the problems that finish. Okay, let's work our way through H. I take a peek, and the first thing I always look for is a common factor. And I notice that I have a common factor of 3 in every single term. Okay, I can pull out my common factor of 3. That leaves me with an a squared plus 4ab minus a 5b squared. Now I look inside my brackets, and I have a simple trinomial again. Squared something, single something, none of them, and then the opposite in the other case, the other direction. So I am looking for two numbers that multiply to give -5 and add to give 4. Well, hopefully we're good on a +5 and a -1. So I could write that in then, as my brackets have to be a plus 5. Look at my b's though, I got to tack on my b, times an a minus. Now I'm going to put in some bad form here. 1b. There I would be factored. I hope we just realized that that green 1 is horrible form, so let's get rid of that, and we would just write it in as a minus b. I think if you got h factored, I think you were doing great. If not, we got a chance to pause it now and give I a shot. If not, here we go. First thing I always look for is a common factor. I notice that I have a common factor of 4 in all three terms. That leaves me with an x squared plus 3xy plus 5y squared. Nice. Now you take a peek, you have a simple trinomial, and now you go, hey, two numbers that multiply to give 5 and add to give 3. Well, there aren't any. Okay, I needed to make sure that I was not giving you the impression that everything always factors further. After tackling questions like F and then H, I start to give this impression like, well, first what we do is we pull out a common factor and then we factor the next trinomial. Well, we have to be conscious that maybe the other trinomial just doesn't factor further. Remember, that question was what we started off with on the day, an expression in which you could only pull out a common factor. So if you have that gold, great, fully factored. Okay, let's take a peek at J. J looks so small, looks so simple. Okay, This is not going to be the way we are going to think about J in the future. But for today, I think it's great. You take a peek at it and you go, wait a second. I have a squared something, but I don't have any single somethings. And then I have my constant on the end. Okay, well then I don't think this one can factor. And you got to stop for a sec. I think if it helps to view it for today, wouldn't I be okay to write this? If I don't see any single A terms, then couldn't I view it as having none of them? Having 0 of them. Okay, could you factor the blue expression? 2 numbers that multiply to give 25 and add to give 0. Well, that would be a positive 5 and a negative 5. The positive 5 and the negative 5, they would cancel out when we bring them together. There's my 0 A's. Okay, so when I factor that, that one actually factors into an A plus 5 times an A minus 5. If we got that one, then I think we are doing outstanding. Okay, I am going to leave you with K for a moment because I think K is a great opportunity for us to really try some problem solving. Okay, pause the video. Okay, we're back. So first thing that I think on K is we should be looking at that going, wait a sec, there isn't a common factor. There's only 2 terms, there's not 3. It's not a simple trinomial because you got the 4 out in front, so that makes it uglier. Okay, I don't think that there's a way to factor it. Can we take a look back at J? J was an instance where we expanded some brackets and we got left with 2 terms, not 3. Then maybe we've got the same sort of thing with K. So maybe I start to build my factors a little bit differently. And I say, well, maybe it could be a binomial times a binomial. Well, now I start to look at the first term and I say, hey, I need 2 things that multiply together to give 4x squared. Well, maybe that's a 2x times a 2x. And then we learned from question J that if I have the same number but opposite signs in between, then my middle terms could cancel out. So maybe then I take a look at my 49y squared and I say, hey, 2 numbers that multiply to 49, 7 and 7. So I would have a 7y at the end of both brackets. Well, how do I get my middle terms to cancel out? I need 1 to be a plus and 1 to be a minus. You take a peek and you re-expand those brackets and you'll notice your middle terms cancel out. You end up getting one term of a negative 14xy and the other term a positive 14xy. There those cancel. Okay, I think question K is a doozy, and as I said, we're going to think about K a little differently in the next coming days. Okay, your job is to get a ton of practice with this. I would probably put today's topic in the top 3 all semester in terms of importance. This is so important for you to get extra practice with this topic to make sure that anytime a simple trinomial is in front of you and it is factorable, then you have the means to be able to factor that thing in somewhere between 5 and 15 seconds. Okay? Jump in and get some practice. Make it as automatic as possible. Good luck.